Hello everyone, welcome back to my channel. Today let's go over a Leetcode hard question that I just solved on my own. So I'm super happy about this, and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let me go over it and let me show you how I did it. This one is called maximum number of robots within budget. Basically, you're given two arrays and you want to find the longest subarray where the maximum value of that subarray plus the sum of the subarray and running costs plus the length of the subarray times the sum of the running costs is less than or equal to budget. So the first thought was just to get every subarray inside of charge times, length of charge times. So this is n squared. It's a brute force approach, but to get the biggest, we're just going to get a sorted list here, and charge times, we're just going to get the maximum, so we're just going to add charge times j, because the rightmost element when you add it to a sorted list will be on the right hand side. And then k is just going to be the length of the subarray, which is just j minus I plus 1, because j is expanding the window. So I, j, and I and j is just going to be like this, vice versa. You guys get the point. And then the sum of running costs, which is just going to be, let's call this total, and we're just going to add running costs of j, okay? Because these are both of the same length, so that makes the job easier. And we can just say the value currently is just going to be curve -1 plus j minus I plus 1 times total, okay? So if value is less than or equal to budget, then we can record the current length of the current subarray, because that's what we're trying to maximize. And then we just return answer at the end, right? So n squared here, it works, but it's going to be a little bit too slow. So let me show you how I optimized it. Okay, time limit exceeded. The idea I had was just to use a sliding window approach. So as long as budget is not exceeded, keep expanding the window. If we're bigger than budget, then shrink the window until we're not anymore, and then take the length of that current subarray, okay? And then after that, we keep expanding, and then if it exceeds, then we shrink, vice versa. So that's going to take the complexity down from n squared to n. So we're just going to put this first, and we're just going to add charge times of I, and then the total sum. So because we want the sum of this, we're just going to say tot is here. We're going to add running costs of I, okay? So we're just expanding the window, and then while cur of -1, so whatever value we have, times or plus, so I minus left, we're going to have a left pointer, plus 1, which is the size of the window, and then we're going to times total is bigger than budget, and left is less than or equal to I, because we don't want the window. So when we're shrinking the window from left to right, we don't want them to cross. Like, you can't have a situation where you have right and then left. That's not valid. So that's the point of this. And then in that case, we're just going to subtract from total running costs of left, because left is the right pointer, and we're going to shrink the window by minusing that value. And then also we're just going to discard from current charge times of left, okay? So same thing, and this sorted list is going to keep everything in order, so that's really handy. And then we're going to increment left forward until this is not set or this is not set. And then when we hit the condition, then we have our longest subarray, right? Because we're going to keep shrinking as long as we're not. So let's say cur and is bigger than budget. So in this case, you can see the length of the longest subarray is left and I. These are the two pointers, so we have to add 1 to it. 2 minus 0 plus 1 is 3. Okay, so now we can say answer is max of answer I minus left plus 1. and then return answer at the end. So this is now n instead of n squared. And if we submit it, and there you go, passes all test cases. So again, I'm super glad that I was able to come up with my own solution to this question without any help and solve it completely on my own. So hopefully that made sense. Thank you for watching and stay tuned for more.